This video, we're going to talk about a rhombus. So you may want to pause for a second if you don't have a piece of paper. Maybe grab yourself a ruler if you got one, or at least something to help you draw a straight line so you can draw a good figure. So then when we talk about it, it makes sense when you look at it. So first of all, a rhombus. A rhombus is a parallelogram. So all the things that we talked about as far as properties of a parallelogram are still going to be true when you look at a rhombus. There are obviously some things that make a rhombus different than the parallelogram. So that's what we're going to talk about. All right. So the first thing we're going to do is we're going to draw a rhombus. So if you don't have a ruler, that's fine. I'm going to kind of use some of the lines on my paper here. At least gets a straight edge of some sort. So we're going to make a rhombus, and I'm going to use the lines on my paper so I don't have to measure. I'm going to go 14 lines. So if you want to draw it the same as mine, grab yourself a straight edge, and we're going to go, let's go 14 lines. All right. And then I'm going to count 7. 1, 2, 3, 4, 5, 6, 7. And I'm going to go ahead and put a little dot there for a second. Okay, so right now you have a line segment. I used 14 lines on my paper, and I counted down 7, put a little dot, and then 7. Okay, so you should be right in the center here. Now, the reason why I'm kind of starting off this way, going back to some of the things we talked about for the parallelogram, this is going to be one of the diagonals of my rhombus. And we talked about that the diagonals bisect each other. Okay, so right now, if you just look at this segment, and I'm going to go ahead and put a little 7 here since it was 7 lines. And then I'm going to go ahead and put a 7 here. Okay, so you'll kind of see how this looks once we start putting it all together. All right, so this is going to be one diagonal of my rhombus. My other diagonal, we're going to go straight across like this, and you can again use the line right on your paper here. And again, don't really have to measure this one. I am going to measure mine since I have a ruler here. I'm going to go 4 centimeters. So I'm going to kind of go 4 here. And if you don't have a ruler, just what you want to do the best you can is just make them equal. So if I had 4 on this side, I'm also going to go 4 on this side. Okay, if you don't have a ruler, just kind of make a pretty good guess, trying to make it look even. All right. And I'm going to put 4 and 4. All right. So right now you're looking at just the diagonals of our rhombus. So what we're going to do is we're going to finish off the rest of the diagram. So again, this is where you need your straight edge so it looks nice. And we're just going to make the sides of the rhombus. So we're going to kind of just go around and connect the ends of our diagonals. So it looks something like this. All right, so there we have our rhombus. Okay, now again, as you can see, it does look like our parallelogram, and like I said, it does have all the properties of a parallelogram, so those are still good. And as we drew it out, again, one of the properties of a parallelogram, the diagonals bisect. So we have a 7 and a 7, and then we have a 4 and a 4. All right, so what else is going to happen in a rhombus? If you're looking at this right now and thinking about some of the things we've talked about, right in the center here, these look perpendicular, okay? And in a rhombus, they will always be perpendicular. So in your figure, I would like you to go ahead and add your little right angle boxes. Okay, so in a rhombus, it will always look like that. All right, so over here, I'm going to put down number 2. In a rhombus, the diagonals are perpendicular. Okay, so every time you see a rhombus, you know that you have 90 degrees in each of these angles right there in the center. All right, that is something that did not always happen in the parallelogram, but it will always happen in the rhombus. All right. Looking at our rhombus again, and just kind of, you can see that the rhombus, once we do those, we have those diagonals in there, we have these little triangles in here. And since we know this is 90, we also know we have a right triangle in here. So to figure out this side of the right triangle, if you look at the right triangle, this is 7, that would be a leg. This is 4, that would be a leg. This is the hypotenuse of that right triangle. So I'm going to do a little Pythagorean theorem so we can get a good guess at this here, since we didn't really measure this. So if this was 7 squared plus 4 squared, that would have to equal my hypotenuse squared. All right. And if we do that on our calculator, I do believe it turned out to be about 8. I'm going to round it to 8.1. All right. And if you look carefully at our rhombus, hopefully you will notice at this triangle, isn't it also 7 and 4 for the legs? That means my hypotenuse here would also be 8.1. If you look at either of these triangles that are upside down, this is 4 my leg, this is 7 my leg, this is the hypotenuse, this would also be 8.1. And the same thing for this one here. All right, so if you take a look at our rhombus, the third thing I'm going to add to my list over here is that in a rhombus, what do you notice about all 4 sides now? All 4 sides, in this case, turned out to be 8.1. So in every rhombus that you will have 4 congruent sides. All right, 4 congruent sides. In a parallelogram, we just had opposite sides equal, and that still is true here. 8.1 is equal to 8.1. All right, but now because it's a rhombus, we actually have all 4 sides congruent. So again, this is 8.1, this is 8.1 also. So all 4 sides are 8.1 in this case for our rhombus. All right, and then one last thing as far as the rhombus has to do with the diagonals. And I'm going to write it over here first, and then we'll go to the picture. The diagonals bisect the angles. The diagonals bisect the angles. All right. So what does that mean? Let's take a look. Go back over here to my picture. So over here, okay, we have this angle here that I now have highlighted in yellow. Our diagonal goes into that corner, and since this is a rhombus, we know that it's going to bisect it. So this big angle in yellow is going to be divided into these 2 smaller angles. All right, so big angle, bisected, 2 small equal angles. All right, and for the sense of our little diagram here, I'm going to say that's 50 degrees. That means this would also be 50 degrees. The entire angle, therefore, was, and I'm going to write it on the outside edge here, is 100 degrees. Okay? Using information from our parallelogram, one of the things we talked about there was that the opposite angles are congruent. So again, that's still going to happen. So that means if this angle is 100, that means this angle over here, opposite, would also be 100. Put that out there. So again, the whole thing is 100. And similar to this side, again, that 100 is going to be divided equally, making this one 50 degrees again and 50 degrees again. All right. And again, that's something special that happens in the rhombus. All right, last corners that we'll take a look at. Okay, so we got this one up here. All right, and we have this one down here. So again, these ones that I now have in orange, we know will be equal because they are opposites. However, they're not going to be the same as these corners. All right, so this corner is the same as this one, which is 100. How do we know what these are going to be here? Okay. So again, going back to parallelogram, the ones that are consecutive or next to each other have to add up to 180. So if this yellow corner was 100, this orange corner must be 80 for the entire corner. The diagonal split the 80, so that means this would be 40 degrees and 40 degrees. And again, those same things will be repeated here. This entire angle is 80 degrees. Again, diagonal split it equally, 40 degrees and 40 degrees. All right, so that's kind of what happens in the rhombus. Again, here's your properties. Again, all the things of a parallelogram still are good. In addition to that, we have diagonals perpendicular, meaning we have 90s in the center. We now have 4 congruent sides, okay, which would be our 8.1 in this case. And now we know that the diagonals bisect the angles. So again, we got 50-50. We've got 40-40. All right, there you have it.